my name is Daniela Orozco, and today I'll be explaining work. However, I will not only be explaining regular work, I will be explaining work by variable force, which in turn we use integration to solve. So, the regular work formula is known as the force times the distance traveled. So this is how you find work on a constant force. But sometimes you have to do work with a variable force. When such is the case, we use integration, and the formula is so this is the formula for work. And so these are the basic formulas. Other formulas that you should know when you're working with work is Hooke's law, which is force equals K times D. You should know Newton's law of gravity, which is force equals G mass 1 mass 2 over distance squared, and Coulomb's law, Coulomb's law, which is force equals K times Q1 Q2 over distance squared. Okay, so these are the basic formulas that you should know when working with work. And these are forces that you should find when you plug in here. However, these are only some of the problems. Other problems are related to weight or expanding gas. When you have expanding gas, you should know that P equals K over V. This is another formula for expanding gas. Now I'm going to show two other examples of work that involve volume and weight. So our first example example number 1 is a cone. Upside down cone. We have here upside down cone. This is going to be our origin. So this is my origin. 0, okay. The top of my cone is at 6. Diameter, I'm just going to write it out, equals 8. And this is feet. And so this is our cone. We have 0, 0, the diameter is 8. This line right here is y equals 3/2 x. Keep that in mind. Okay, so first thing off, when you're doing work problems, you draw your diagram. So step number 1 is draw a diagram. We've done. Number 2, you have to find out what your force is. So in this, also draw your representative rectangle. So this is your representative rectangle. This shows where the water level is. And we're pushing the water out. So force is going to be the volume of the weight of the water. Okay? So weight is, okay, so I'm just going to write it here. Force is equal to the weight, which is equal to the total volume times the pressure. So for water, pressure is equal to 62.4. That's what you need to know. So that's the pressure. And pounds, by the way. And then we have to find the volume. So the volume is going to be, this is total volume, is equal to, and so the volume is going to be, you have to find the volume of each layer, and each layer is going to be the circle, correct? So I told you to remember y equals 3x squared. So we want this in terms of x, and therefore x is equal to 2/3 y. So each layer, which would be your circle, is going to be 2/3 y. That is the radius of your circle. So radius equals 2/3 y, because each layer is a circle and the area of a circle is pi r squared. And so then it's equal to 2/3 y squared times pi. Okay? So our force in turn is going to be 62.4 times 2/3 y squared pi. Now our height is always the top minus the bottom, so it's 6 minus whatever y is equal to 6 minus y. So that's the height. Now, with this information, we have our force and our height. We can move on to the actual problem. So we know that work is equal to the integral from a to b of force of x dx. So this is equal to, and so we're trying to find, for this, is empty the empty cone. We're trying to get the cone empty. So our integral is going to be from 0 to 6, because this is 0 and that's 6. And our force we have is 62.4 times 2/3 y squared pi. And you're going to multiply that 6 minus y. We can then continue solving out your integral. 62.4 times 4/9 y squared pi 6 minus y. Take out your constants. 62.4 times 4/9 times pi. The integral of 0 to 6 of y squared 6 minus y. And then continue on, equals 62.44 divided by 9 pi. And integral 0 to 6 of 6y squared minus y cubed. Make sure you have the dy. dy, don't forget that. dy. It equals to 62.4, 4 divided by 9 pi. Integral is 2y cubed minus y to the 4th over 4, 0 to 6. You plug it in, and your final answer is going to be 9409.7. You can plug this into a calculator once you get done. But this is beats pounds. This is your final answer. And this is for a cone that is having water pushed out. Example number 2 is involving a chain. This one's slightly, I think, easier. So you got a chain. We want to lift chain until 10 feet off ground. Okay, here's our origin. Here's about 10, this is 20. The chain's 20 feet long and it's hanging 20 feet off the ground. We also know that the weight of the chain is equal to 3 pounds. That we know. It's given to us in our problem. So now we know that force is equal to W times delta Y equals 3 delta Y. So we have to find distance. Well, distance is top minus whatever, so it's 20 minus y. So we have our weight, we have our force, we have our distance. Now all we have to do is integrate. And we're just going to draw this there. Okay, so integrate work equals. Okay, so we're doing it until it's 10 feet off the ground. So it's going to be from... My bad, sorry. It's not from 10 feet off the ground. Yes, we're lifting it all the way up. And so, therefore, you have 3 pounds times 20 minus y dy, and our integral 0 to 20, and equals 0 to 20 of 60 minus. And honestly, you can take out the 3, so it's just 0 to 20 equals 20 minus y. dy equals 3 times the integral of 20y minus y squared divided by 2. And that equals, in turn, 600 feet pounds. And that is the final answer. So that's example 2 with the chain. I'm sorry about this. Just lift the chain all the way up. And so that is how you do work.